We are doing 5.1, which is defining a polynomial. Anybody know what polynomial means? I don't know if you've done this before. Well, let's just look at this poly. What does the word poly mean, or the prefix poly? Eva? More than one. So poly means many, and nomial, this part here, is referring to terms. And I'll show you what I mean by different terms, but this basically means many terms. And then, so polynomial is what we would call all of them together, but then there's different types or specific names. A monomial, binomial, and trinomial, they're all examples of different polynomials. So they all fit under that umbrella of a polynomial, but they are the specific names. So just by looking at it, any idea as to what the prefix, you know what prefix means, right? You've learned about prefixes in English. What's the prefix mono? You can just call it out. It means one, so that's when we have one term. So I'll show you an example. If we have something like, well, just a whole number, like if we had the number 15, that would be an example of a monomial. If instead I had something like 2x, the 2 and the x, like even though you have two different things there, they're stuck together as one unit. We only consider them different terms if there's a plus or minus sign in between them. That make sense? Even if I had something like 5x squared y, so there's a whole bunch of stuff going on there, I still count that as one term because there's no plus or minus sign in between the different things going on. So it's like they're one clumped together unit. We kind of have some experience with this, kind of like yesterday when we were moving the 2x to the other side of the equation. Remember we treated it as a stuck together clump and did minus 2x to move it over? That's because it's one term. Binomial, what do you think that binomial means? How many terms? There's two terms. So if, well, why don't I take the first two here and combine them? 15 plus 2x would be an example of a binomial. If I had something like 3x squared minus 2, that is still a binomial because the minus sign is separating them, but this would be 1, 2 different terms. If we had something like 5x squared y minus 3xy cubed, there's a lot of stuff going on there, but they're only two separate terms. Do we get the idea of that definition and what they are? And then trinomial, I feel like you probably know this. What's a trinomial? 3 terms. So we could have, let's say, x squared plus 5x minus 2. I only consider them separate terms because, do you see that they're not like terms? I can't combine them because this is an x squared, but this is only an x to the power of 1. If this had been an x squared as well, I could just combine them together, which we've done before, but they're separate. There's an x squared and then an x, and then just a whole number. So this would be considered a trinomial or 3 different terms. Lots of different ways this can show up. I could have 3x squared y minus 5y plus 2. I could have 5xy cubed minus 3xy plus 4x. So there's different things going on in each of them, but to make this clear, there's 1, 2, 3 terms there, 1, 2, 3 terms there, and 1, 2, 3 terms that are right there as well. Questions about that? We're pretty okay with that? Okay, let's analyze and look at the different parts of our terms as well. So you know how I'm going to take this as an example. So in this, does everybody know what the coefficient is? What's the coefficient in that example? Yeah. So I'm going to label this, that's the coefficient. Coefficient is the number that comes before the variable. And what is the variable? What are the variables in this term that we're looking at? X and Y, so that and that are both variables. We generally tend to use X and Y, but just to be clear, we could use any letter that we want. So if we're talking about value in a question, we could use V. If we're talking about cost, we could use C. It doesn't matter. So you get to choose, but in word problems, usually it's easier. It's like an organizational tool to, if we're talking about cost, if we use C, when you go through all these calculations, it'll be easy for you to remember what that even represented if you use a C for it. Make sense? Okay, and then the degree is another thing that we're going to look at, but I think this is getting a little bit messy, so I'm going to show you using a separate example. So degree is something that I'm thinking is probably brand new for you. That is the sum of the exponents of the variables in that term. So if we have 3x squared, the degree of this, the degree is 2. So we are talking about that part. In this case, there is no sum. Do you know what sum means? What does sum mean? The answer to addition, so when we're adding things, right? But there's nothing to add there. So there's a 3x squared, we just use the 2. So let me give you something that has a little bit more going on. If we have 5x squared y, then we want to know the degree in this case. What is the degree in this case? Yeah, it's going to be 3. So you know how whenever you see a variable like y or just an x, we never write it, but there technically is a little 1 at the top. When you go to find your degree of that term, you include that little 1 that's at the top. That's actually invisible. We don't normally write it. Good? So that's a common mistake I see. People forget the variable that doesn't have the exponent written up top. Make sure that you do include that and you do use a 1 in order to do that. Okay, so if we have something with a little bit more going on still, a cubed b to the 2, what is the degree of that one? Of this term? Yep. 3 plus 2, so the degree is just 5. So we're good with degree? The first section of a chapter is usually a lot of vocabulary and setting up the basics for the stuff we're going to be working with. So that's what this lesson is about. I feel like you've pretty much gotten that. But there is one other thing that happens with this. If we want the degree of something that has more than one term, so let me show you an example. If we have 3x squared plus 4x plus 1, first of all, let me bring your attention to a pattern of behavior with this. Notice how I've written these 3 terms. So this is a trinomial. There's 3 terms there. Do you notice how I'm writing them? What's a pattern that you notice with the order or the way in which I'm writing these? Snoo? Good. So it goes from x squared to just x to no variable at all. We call that descending order. Everybody knows what the word descending means when it's going down. So descending order of the exponents. So you always start with the largest exponent and then go down. And this number that's at the end, notice how it doesn't have any variables on it. We call that a constant. Have you learned that before? Yes? Good. So if we want the degree of this entire polynomial, of this entire trinomial, we always look to the lead term. So this is our lead term. And I would just ignore the rest of it. So I would look at this and say this is a second degree trinomial. This is how I properly name this specific polynomial. I talk about the degree first. I look to the lead term to find that. And then I talk about whether it's a monomial, a binomial, a trinomial, anything past trinomial. So if it has 4 or more terms, we just call it polynomial because it will get ridiculous. And hopefully we won't have many with more than 3 terms. Good? So far so good? The only other thing that I can say about this is if we have an example, well, why don't I just show you? If we have an example like this and we want to simplify, we have 2x squared y minus 3x, and I do want you to try this one on your own, 4x squared y minus 15x. First of all, in order to simplify, we look for something called like terms. Do we know what like terms are? Yeah. Yeah, so the term has the same variables in it, and the variables have to have the same degree as well. If they have the same letters and the same degree on those letters, we can consider them like terms and we can combine them. So let me show you what I mean. If we have 2x squared y, is there anything in there that's a like term, that's considered a like term to that? Yeah. The 4x squared y. So the reason I'm saying that is because of x squared y is the same as x squared y. So you see what I mean with the variables and the degree? So it's basically like you're just counting up how many of those we have. So how many of those do we have? Yeah, you basically are adding the coefficients, right? So 2 plus 4. So we would get 6x squared y, and that accounts for this and this. To look for another like term or set of like terms, I have minus 3x and I have minus 15x. So it's like I'm counting up how many x's I have. They are like terms because this is an x to the 1 and so is this one. So how many do I have? If it's a minus 3 and I'm taking away 15 more, I'm going further into the negatives on the number line. Where do we end up? Hiva? Negative 18. So we have negative 18x. Is everybody good with that? Let's also name this. I didn't ask you to do this, but we might as well just to practice. If I want to name this polynomial, where do I start? What comes first? Yeah. Yeah. So third. Yes. So this would be a third degree. There's 1, 2 terms here, so third degree binomial. You just went. Third degree binomial. Do we get that? And how to name that? And we feel pretty comfortable with that? Okay, one last thing and then we'll quit this and move on. Oh, I'm going to show you stuff that are not polynomials because this can be confusing. So in order for it to be a polynomial, we have coefficients, we have variables, we have little exponents at the top, we have plus and minus signs in between. But if we have x to the negative 2, so if we have a negative exponent, that is not considered a polynomial. That's considered something else that we won't talk about yet. It's a rational function, but you don't need to worry about that yet. That'll come up later. Also, if we have x to the 1/2, So fractions in the exponent, negatives in the exponent don't count. Root x, if we have a square root sign over the variable, it doesn't count. So how would this look in a question, or how would this show up? If we have 2x squared minus root y plus 3, this is not a polynomial. Make sense? Eva? Yeah. Yeah. No, it's still just third degree binomial. So when we're naming the whole polynomial, we only look to the first term. Make sense? Okay. I think we're good to go. So here's what I'm going to get you to do. I'd like you to right now work on 1 to 5 and 8. For all of these, you're going to only do the odd letters. At this point, does everybody know what I mean by odd letters? A, C, E, etc.?